Hello students, in today's class I will help you understand what a linear equation in two variable is. So let's start. Linear equation in two variable. Let us start by giving you a simple situation. Okay, the situation is, let us say that the total students in a class is 40. Okay, I am giving you this condition that the total students in the class is 40. I am not telling you how many boys and girls are there. So let us assume that boys, okay, let the number of boys be X and number of girls be Y. So let's draw number of girls be Y. Total number of the students is 40, number of boys is X, and say number of girls is Y. Now, mathematical expression for this situation, if we want to express this situation mathematically, it would be X, that is for boys, Y, that is for girls, and the total adds up to 40, which will be like this. Okay, now let us take this 40 to the other side, like this. It will be X plus Y minus 40 is equal to 0. Because here 40 is plus 40. When it goes to the other side, it becomes minus 40. Now students, this X plus Y minus 40 is equal to 0. This is called a linear equation in two variable. Let's see why this is called a linear equation in two variable. Okay, let me write it over here. X plus Y minus 40 is equal to 0. Let's add 1 to them. Yeah, 1x plus 1y minus 40 is equal to 0. Now, we have to understand one thing, because the topic is linear equation in two variable, right? It is equation. So equation is, this is called a linear equation in two variable because of this equal to sign. This equation means there has to be an equal to sign. Now the next thing, two variable. Variable is the alphabet. So what are the alphabets over here? X and Y are the two alphabets, right? So those are variables. So how many variables we have? We have two variables. So equation in two variable is done. Now this word linear means that, listen carefully, the word linear means that the highest power of these variables will only be 1, right? Highest power. What is the variable of this X right now? It is 1. What is the variable? Okay, what is this variable Y? What is the highest, what is the power of this? The power of this is still 1. Okay, because the highest power is 1, which we normally don't write, right? If it is X, it is Y, it is assumed that the power is only 1. We don't write it. So 1x plus 1y minus 40 is equal to 0 is a linear equation in two variable. Linear because the highest power of X and Y is 1. Equation because it has an equal to sign. And two variables because there are two variables, two alphabets, X and Y. Now let us see what is a general form, because you will hear this word also, general form of a linear equation in two variable. What is a general form? General form is like this: ax plus by plus c is equal to 0. This is a general form for a linear equation in two variable. Ax plus by plus c is equal to 0. Let us put this into this. It will be 1x plus 1y minus 40 is equal to 0. So here, to be very specific, let us try to find out what is the value of a and b and c. So a, what is the value of a? See, a is always in front of x. So what is in front of x is 1. So a becomes 1. Let's try to find out what is b. B is always in front of y. So in front of y, we have got 1. So b will be 1. What is c over here? Whatever is left without a variable is called c. So here it is negative 40. So that becomes the value of c, right? So if I give you a linear equation in two variables, will you be able to find out what is a, b and c? Let me give you one example. Okay, let us take this example. Okay, and you have to tell me what is a, b and c. Okay, the equation is 3x plus 2y plus 60 is equal to 0. Okay, come on, let's solve it together. First, whenever you see a linear equation, what you have to do is, below this equation, okay, write down the general form. What is the general form? General form is ax plus by plus c is equal to 0. Now what are you going to do? You're going to see what is in front of x. That becomes a. So our a would be 3, right? What about b? B is in front of y. So b would be 2. Yeah. And what about c? C would be whatever is left out, that is plus 60. Or we write it simply 60. See, how easy is it? Is it easy to find out a, b and c? Okay. Now, we have to remember one more thing when we talk about linear equation in two variable, is that always this a, b and c, right, they are real numbers. A, b and c. So whenever you write that linear equation in two variable can be expressed as ax plus by plus c is equal to 0, we also have to tell them that a, b and c are going to be real numbers. And one more very important thing, and that is that the value of a and b should never be equal to 0 at the same time. Okay, that's it. So in this video, I have helped you understand what a linear equation in two variable is, right? What is its general form? General form is ax plus by plus c is equal to 0. It is called linear equation in two variable because it has got two variables. It has got an equal to sign, and the highest power of those variable is 1. And if I give you a linear equation in two variable, now you can very easily find out what is the value of a, b and c in a given linear equation. Hello students. In standard 9, you have already learned what a linear equation in two variable is. So in class 9, you have learned that a linear equation in two variable can be written as ax plus by plus c is equal to 0. Now in standard 10, the chapter's name is not linear equation in two variable. The name of the chapter is pair of linear equation in two variable. Okay, so in class 10, it is pair of linear equations. pair of linear equation. So let's see. This is the general form for a linear equation in two variable, which you already know. Ax plus by plus c is equal to 0, where a, b and c are the real numbers and a and b cannot be 0, right? Together a and b cannot be 0. Now let's see what is this pair of linear equation and what is its general form. So when we talk about general form of a pair of linear equation, it's almost similar to standard 9. So look carefully, okay? Ax plus by plus c is equal to 0. I'm going to write it 2 times. Ax plus by plus c is equal to 0. Why I'm writing it 2 times? Because of this word pair. So it is 2. Okay, now both of them look similar. So how will I differentiate them? So this becomes a1, this becomes b1, and this becomes c1. Okay, this becomes a2, this becomes b2, and this becomes c2. See, it is that simple. So let me give you one example also. Let's take any equation, any random equation like 3x. What should I take? Anything. Say 3x plus 2y plus 7 is equal to 0. This is my first equation. Let the second equation be like 2x plus 7y minus 10 is equal to 0. So now this is a pair of linear equation. Linear equation. A pair of linear equation. We have to find out what is a1, b1, c1, which will be very, very simple. Let's do that. What's a1? A1 will correspond to the value of x in the first equation. So this is going to be a1. So my a1 would be 3. What about my b1? b1 is 2. What about c1? c1 would be this whole thing, which is 7. Okay. For a2, I have to go over here. This is 2. What is b2? b2 would be 7. What is c2? c2 is 10. But remember one thing. c2 is 10 with a negative sign. So it will be minus 10. This is the place where some of the students make a mistake. They write 10. They forget about this negative sign. So negative sign always goes with that particular number. So the value of C2 is minus 10. Okay. Now, you have also studied in class 9 that in the graphical representation of a linear equation, if you're going to represent a linear equation in the form of a graph, that will be a straight line. That will always be a straight line like this. Graph, you all know, got 2 axes like this. One of them is the x-axis, one of them is y-axis. X-axis is also called abscissa, right? And y-axis is also called ordinates. Okay, and this is the origin over here. So linear equation in one variable in standard 9, you have learned that the linear equation in say 2 variable can be drawn graphically with the help of a line. So this is a line. Let's assume that this is a line for this one, which is 3x plus 2y plus 7 is equal to 0. Now in standard 10, because it is a pair of linear equation, so we will get one more line on the same graph. So let's assume that this is the other line. Okay, let's say this is the other line for this equation. It's just assuming it. 2x plus 7y negative 10 is equal to 0. So there would be 2 lines, there would be 2 straight lines drawn in a graph. Now, if we are drawing 2 lines in the same graph, then there are a total of 3 possibilities. What are the 3 possibilities? The 3 possibilities are like these lines, okay? The first possibility is that these lines could intersect. Second, these lines could remain parallel, or third, these lines could superimpose over one another. Let's see all the three conditions in detail. Okay, let us see the first situation for these two lines. These two lines could, on a graph, they could like meet at one point. If they meet at one point, you call them intersecting lines. You call them intersecting lines, right? And these intersecting lines, in our chapter linear equation in two variable, we also use one more word, which is because if they are cutting at one point, you call it as unique solution, right? It is called unique solution. Okay, the second situation is these two lines, I told you they could cut each other, or the second situation is they could be remain parallel to each other like this, not touching each other at all. So if they remain parallel, they're called parallel lines. Okay, and for parallel lines, we use the word no solution. We use the word no solution. Now the third situation is, this is the graph of the first linear equation in two variable, and this is the other. That means they are superimposing. They are on each other, right? Such lines, we call it coincident lines. Okay, and coincident lines are called, they have infinite many solution. So the word used is infinite many solution. Okay, the first one, where the lines are cutting at one point, I told you they are called intersecting lines, and or we call them unique solution. There is one more word which is sometimes used, and the word is consistent. They are consistent pair of linear equation. So we have to remember that also. Consistent. Let me write it over here. Consistent. So they are consistent pair of linear equation. These two lines. Now, the other word for no solution is, because they're not touching. Consistent means they are cutting each other at least at one point. Okay, here they are not cutting each other. So no solution means it is called as inconsistent. Okay, no solution is inconsistent. Infinite many solution, we use the word dependent consistent. Okay, so let's see this. Intersecting lines are called unique solution, okay, or consistent. Parallel lines are called no solution or inconsistent. Coincident lines are called infinite many solutions or dependent consistent. In standard 10, there is some conditions also which we need to remember for them. Conditions, what do you mean by the word conditions is like if you want to find out whether these two lines are going to remain parallel or whether they are going to intersect at one point, or are they going to form a coincident solution without drawing them on the graph. Just by looking at them, if you want to find out, there is a way for that also. Okay, so for that, for intersecting lines, for unique solution, the condition is A1 by A2 is not equal to B1 by B2. What does this mean? You will be given two equations, right? You have to write A1, B1, C1, A2, B2, C2, and then find out the ratio of A1 by A2 and B1 by B2. If the ratio is not same, then those lines are going to intersect. You can confirm it by drawing a linear equation in two variable graph. later on. Graphically you can confirm it. Okay. Condition for no solution is A1 by A2 is equal to B1 by B2, not equal to C1 by C2. Okay. If A1 by A2 not equal to B1 by B2, the story ends there itself. It will be an intersecting line. But if in case A1 by A2 comes equal to B1 by B2, we need to check C1 by C2 also. And if B1 by B2 is not equal to C1 by C2, then the lines would be parallel lines. No solution, inconsistent. Now the third one is very simple. The third condition is A1 by A2 is going to be equal to B1 by B2 is going to be equal to C1 by C2. Right? You find out the value of A1, B1, C1, A2, B2, C2. Find out the ratio of A1 by A2, B1 by B2, C1 by C2. If all the ratios reduced to their lowest terms are equal, then the lines definitely are going to be coincident line, infinite many solutions, or dependent consistent.